Hi, I'm Domen. I come from a little country called Slovenia, about 2 million inhabitants. I'm really excited to be invited to speak at this conference. I want to tackle a topic that's very hot at the moment, and that's, well, DevOps. I like to split it into 3 categories, of which DevOps covers only one part. And I've given this talk at EuroPython, so if you've seen it there, I'm sorry to... It's going to be a little bit updated version, but more or less the same. So in Python, we have, by my opinion, 3 big problems with packaging. So the biggest problem is that setup PyScript that we use is dynamic. So if you want to know the dependency of a package, you have to run setup Py. You actually have to execute a script to get the dependencies to know like what are the dependencies for Python 2.6, because people put conditionals in there to include extra dependencies and so on. And very few languages do that, and it makes packaging really, really complicated. And there is a solution to this. There is a PEP 4.2.6, which is in draft mode at the moment, but I really hope that one day it will get to the final version and it's going to get used. The name is metadata 2.0, and it's basically a JSON file to describe dependencies and so on. Like, for example, for Node, you have that in JSON. The second thing is we have a lot of legacy. We have dist-to-tool, setup tools, distribute, and so on. A lot of tools that monkey patch each other and so on. And there is a lot of work to make that sane again. And there is a Python packaging authority, basically a group of people who want to improve that. And there is the third group of problems that I don't think we can solve this in Python itself, and that's basically how to package Python with other software that is not written in Python, right? So we try to do that for C in Python. It works kind of nice, but as soon as you go into other domains, this complex gets better. This problem gets more complex, and I think that general solutions that actually wrap all the languages and that's a package manager are better suited to be solved in a general domain than in the Python domain. So we are in 2014 and choose the best tool for the job, right? We were using in the web JavaScript stack. It's almost inevitable not to use JavaScript. So do we want to write tools to package JavaScript in Python, or do we want to use the JavaScript tools that people wrote for their domain and make that a little bit saner? So before we tackle that, I want to do a little bit of foreplay and show you the difference between a stateful solution to the problem and a stateless solution to the problem. So this is a very simple task. I'm sure that everyone that's done web has implemented it. Sweet. So, well, I can explain 2 slides without slides. So if you want to verify an email of someone, you generally generate some random key. Okay. Well, so you will want to generate a key, you store it in the database, and then you send an email to that person with that key, with a link, including that random key. And when the person will click that link, you will check your database, and if the key is in the database, that means that he got that email, and you're sure that he has access to that mailbox, right? So wait just a second. So that's a very simple protocol, but it involves state, right? We have a database from which we store the key, and then we verify it. And that's not a problem. Okay, we can write that code. It takes some time to write the migrations to add that new field. or a table, or however you want to implement that. And there is some edge cases to cover. So there's the question, can we do this in a more simpler way, in a way that we don't have to use the database, so there is no state? How do we verify an email this way? So let's just quickly go through this. So we will use a little bit of cryptography, and there is a package called It's Dangerous in Python. And it implements... What? Okay, it's the box. So it implements the HMAC algorithm, which is, if you know, typical hash function to generate a hash of some content. It's very similar to that, except that you supplied a secret key, and only with that secret key you can generate that hash. So we generate the hash using the email of the user, and in this case we use the timestamp signer, which also includes the timestamp in that hash. And then we send that hash to the user in content of the email, and when user clicks that link, because we are the only one who have the key, the super secret key, we are the only one that can verify that he could not forge that hash. And there is an extra parameter to also then use that timestamp to say, okay, you have only 24 hours to register. So it's like a few lines of code instead of using the database. So with a little bit of cleverness, we've eliminated a lot of code and edge cases. And we want to do the same for packaging, right? So where is state in packaging? There are many different states, but the main one is the file system, right? So when we have the package, basically we give the file system as input. So /user/include has all the headers, and when you compile something, it will go there, and /user/local/include and so on, and it will build the package with all those headers. And then you build another package, and so on and so on. So it always picks this from the file system, and nobody has really a great idea what's going on, what's used, if you compile software on your own, right? That's why we all use distribution, because they have their own system how to tackle this problem. But it gets really complex, and more that things that you build your own, the less you know what's really compiled to what headers and what uses what dynamic libraries and so on. So what if we could eliminate that state, and we only specify some instructions, some metadata about the package, and everything else is deterministic. There is no state, there is no this feedback loop. So that's what Nick's project tries to solve. And it's a purely functional language, very minimalistic. So think of it as a configuration syntax and some Lambda functions. And it tries to apply functional programming ideas to the packaging. The language is lazy, evaluated, and dynamically typed. We'll see more about it later. Currently, it runs on POSIX, and it could work on Windows. Actually, there is, I know there is some work done to support also Windows, but until that's actually finished, we cannot claim that. And it tries to tackle also the dependency hell set of problems that we see quite often. It was developed by Ilko Dostra as part of his PhD. I think there are about 9 papers, scientific papers, written around 2004 to 2007. But now it's stable enough and usable for production, I would say. It's 11 years old project. So let's quickly see what's going on in the package manager. So yeah, my talk is going to be a little bit technical, so please don't fall asleep. So we define in Nix, software package is an output of a function that is deterministic. It only depends on the function inputs, so the metadata that I talked before. And the result is stored in a path like this. So inside /nic/store there is a hash, and then the package name and the version. And inside that folder we have /lib/bin and so on and so on. something that we typically install into /user. And Nickstore is mounted as read-only, so you cannot modify that. Only the package manager can write to Nickstore. This is to ensure that you can really not touch those files. So this would, I don't know if you can see that, it's a little bit small, but I will try to explain a little bit what's going on. So this is an example of an Nginx package, and there are basically two functions that are the most interesting ones. One is at the top of the file. It gets all the dependencies that you want to use to build the package. And then there is the make derivation function, which actually does the all heavy lifting. And that function will then, once it's evaluated, create that path in the Nickstore and use all that metadata that you see here specified to build the package. And nothing else except these information here should affect the package. And there is also a parameter called build inputs, where you specify the dependencies of a package. So it will first build those and then go down up the tree to build the Nginx itself. So one of the features that come out of the design of Nix is that it's very hackable. So for example, typically if you use Debian or something, to modify that Debian, you have to go through a lot of things. You have to know the workflow of how to actually package Debian. But in Nix, we provide two functions to help with that. And one function is to override the top level function that you saw before, the one at the top, and that's override, and the second one is override derivation. And that actually changes the attributes of the package. So you can say, okay, Nginx override, and let's specify another open SSL version. And that returns a new Nginx package with a new open SSL. That's how easy it is for a user to customize those packages that ship. And for example, with override derivation, you can change the source. So instead of using the upstream version, you can say fetch from Git the latest revision from master branch and so on. So as I said before, you can use Nix on POSIX systems, so you can use it alongside with your distribution. There is a two-liner script to do that. You can also do it the manual way if you want to, but this is the easiest way to install it. So this is probably the most important image and representation of how then we actually get from those single packages to an actual working environment. And on the right side, you see Subversion and Firefox packages. And those packages then symlink all the binaries into the user environment, and that's essentially what you have today as a file system. So everything is symlinked together into another package, which is basically a collection of all the others. And then the user environment is symlinked to a profile, and profiles are basically a way to say that you have a set of packages. So each user can install packages in their own profile, and there is a system profile for the whole, that works across the whole Linux distribution that I will talk about later. And those profiles have a history, so all the operations you do, if you install something, if you upgrade, if you uninstall, everything is atomic, and everything keeps a history. That gives you the power to roll back. So something goes wrong, you say roll back, and you go to previous version. And the way that Nix achieves the property of being atomic is that the last thing that's done is the symlink to point to the latest profile version. And symlink by design in Unix is atomic. And everything else is built before that final switch. Okay, so let me show you a bit of a demo. Just a second. Okay, so here I have a very simple Nix package, and it basically just says, okay, there is no source, the name is env, and these are the dependencies. Actually, before that, let me give you a short intro. If I list all the packages in Nix store, this is basically my system separated into folders. And if you look where the zip executable points to, it's inside my profile for my user. And if we actually follow that symlink, you will see that it points to the package that is stored into the Nix store. So when the profile is updated, it will point to another package that has a different hash, and it will use that package once that final switch is made. So if you look at the libraries, you can see that they're pinpointed again to a specific package with a specific version. So there is no way that something non-deterministic happens. They're built specifically with these libraries, and these libraries are not removed. And as long as they're not removed, Nix will not allow you to remove them. The package will work. And this is what we call closure. So every package has a whole dependency tree of packages, and altogether they are a closure, so a complete set of runtime dependencies. So, of course, we do Python, and we want to package Python alongside with JavaScript or something. And there is a package, there is a function called build Python package that does some of the boilerplate things for you, but at the end you use it the same as you would use the make derivation function. You specify some dependencies, and you can package pillow, which is a pill fork in this case. There is also the meta attribute to put in some extra information. So there are essentially three ways to package Python dependencies. One is manually, one is with Python to Nix, which basically just generates like a template that you have to change a little bit yourself. And there is a tool called PyP to Nix that grabs the dependencies from your setup.py file and generates the Nix files for you. It tries to do that automatically, so of course it doesn't cover all the edge cases, but it tries to do that. So another really, really useful tool, I think this is the biggest selling point of Nix, is Nickshell. So think about virtual environment, but for all the software packages that you can install in your system. So you can isolate not only the Python packages, but like Git, Subversion, editor, and whatnot. And you can give this tool to a Mac developer or Linux developer, and they will get the same environment with the same tools. And this is something that I don't know any other software that does, well, except Docker and other software that tries to solve this by isolating it with virtual machines. But Nickshell does that just by using those packages and providing a bash environment, setting the path and so on. So this is how you would use Nickshell. You create a simple file, you specify inside all the dependencies, and then you say Nickshell, and you get all the dependencies from that package, right? So in this case, we would get virtual environment, zlib headers, libjpeg, and git, and so on. There is an extra flag called pure, and that eliminates your system packages. So you will only get the packages that Nickshell provides, and everything that is installed on your system is not available in that shell. So let me show you that. All right, so here we have again a very simple Nix package. And inside there you see I have specified pip. So currently on my system, if I say pip, I don't have it installed. It will say, okay, you can type pip and Python 2.7 and so on. But you don't have it installed, right? So when I say Nickshell, it will download all the dependencies, but because they're already downloaded on my laptop, it will just activate that shell. And now if I say pip, I actually have pip available. And if I pass it a pure argument, for example, and I say less is not available because I don't have it specified as a dependency in that package. So only the packages that are specified in default.nix are available. This is to actually test that if you have some tests and so on in your package, you can run them and you can be sure that everything you have is specified correctly and that nothing is used from your system. So if you think about what is then a distribution compared to just a set of packages, it's basically just a set of files that lay around and those packages use it, and that's the configuration files. So if we can store packages in Nix store, we can also store the configuration files and use that as a distribution. So NixOS is by default declarative, so the only way to use it and to configure it is the DevOps way. So you have one file where you specify the state of your system, and you can say like firewall enable open ports 80 and so on for TCP, and enable SSH. And here I have example of enabling Moonin and so on. And when I say NixOS rebuild, NixOS will make sure that my distribution will have all these packages available, that Moonin will be running, SSHD will be running, and that firewall will be enabled, and so on and so on. It won't care about the current state of the system. It will only take that file and reflect it into the state of the system. This is somewhat different to Puppet and Chef and so on, which tries to, those tools try to figure out the state of the system and then change it into the way that you specified. Whereas Nix doesn't try to figure out that state, and that makes it way easier to use and to figure out the bugs and to figure out and also to write modules for Nix, of course, by my opinion. So my favorite Python framework is Pyramid, and here is a small example, which probably, again, you don't see if you're not in the first 3 rows. But essentially, it defines a system a service where it says, okay, run this command, and you will see the pyramid, and you will execute the pyramid script to run the web server and pass it the init file for configuration. And the same you can do for Django and so on and so on. And to even to expand that idea, the Nix family has a tool called Mixups, which is for deploying NixOS machines into the cloud and so on. It does provisioning and configuration at the same time. So it supports currently VirtualBox, normal machines running just, you specify SSH port and that's it. Hetzner, EC2 Amazon, and Google Compute Engine. And there is plans to support Docker and DigitalOcean soon. So you have 2 configuration files. One is the logical, that's what I've shown before, the NixOS configuration. In this case, that's where it says trivial.nix. And I only enable Apache in this case and specify to serve it Valgrind HTML docs. And the second file is the physical configuration, and in this case I configure a VirtualBox, and I say, okay, use 1 gig of memory, and we will deploy using VirtualBox. And then at the top I say Nixups create, pass you those 2 files, and then Nixups deploy, and it will provision a VirtualBox machine, and there will be Apache running inside of it. So all this goes into a one slide, how to configure the machine and how to provision it, and you have it running. So let me show you that in a demo. So let's first show a little bit complicated project that I had that included pyramid, complicated in terms of dependencies that are not just Python. So I had pyramid, I had dbus, GStreamer, a lot of GStreamer libraries, and then robot framework, if you know, that's for running Selenium tests, and so on and so on. And in this line here, you can see that I override the GStreamer plugin's bed and enable the flag support, which is unfree and it's by default turned off in Nix, and it's that simple to turn that flag on. This is somewhat similar to Gentoo use flags if you're used to that. Just that in this case it's a feature of the language. So if I say Nickshell, it will activate and build all the dependencies and the package. And if I say Python import dbus, I have dbus available. So if you actually want to build the package, not just get the environment, there is a command called nixbuild, and at the end it will output the path where your package is built. And then there is a command called nix copy closure, and you specify SSH domain and port, and it will copy that file to that machine or more machines, and that's how you distribute at the low level if you don't use Mixups software with Nix. So a typical project, if I would use Nix, would look something like this. There is a setup.py file and default.nix. And default.nix serves for two purposes. One is for shell activation for building the package. And then we have the folder called Nix, and inside there is a Mixups specification, how to deploy that package. So if I list that file, you will see example machine.nix and example machine minus virtualbox.nix. And usually I will create then also example machine minus production.nix. So I would test everything first in my VirtualBox and then deploy it to production. So in this case, I only have pyramid as a dependency, and there is nothing else specified, just for sake of simplicity. And then if we take a look how I specify the machine that we will now deploy, I import that default.nix, so that's my Python package, and I assign it into a variable called my project. And then I configure the window manager, desktop manager, and display manager by using i3 and so on. And in this case, I say desktop manager is going to be just wait for 3 seconds and then spawn a Chromium in kiosk mode. And that's going to be what machine is going to do. And it's going to open up a local host under port 8080. And then at the bottom, I specify the systemd service that will run the process, which is just some mostly boilerplate. You specify the package and the user and so on. And at the bottom of the file, I define the user guest with all the properties that I wanted to have. And then again, the VirtualBox file is just, the backend is going to be VirtualBox, and it's going to be 1 GB of memory that we're using. So now, if I say Mixups create sample, so if I say create, that just gives the metadata to Mixups, and it uses SQLite file to store that information. And Mixups deploy minus the example. And the identifier is example in this case. So now it's creating a VirtualBox image, and once that's done, it's gonna spawn a VirtualBox machine. And well, if everything goes well, you will see a full screen Chromium with a very simple pyramid application running. So I guess we can take questions in the meanwhile until this actually works.
How do you solve the problem of different libraries required for other libraries in the same process? So if you have two libraries and they both need the same library but different versions.
So
incompatible versions in the same process.
Right. In the same process. Well, Nix stores software in different packages, right? So we can point to different libraries. Now, I'm not sure, are you talking about Python libraries or C libraries? Shared libraries. So this would be the same as everywhere else. If there is a mechanism to do that, to point to two different specific dynamic libraries, that you can do the same in Nix, right? If you can use that. But Nix doesn't touch the executable itself at all. So, yeah. Not sure if that answers your question, but. No, it's not working. Yeah.
Similar for Python. If in build-out I can have different syspass, so Python passes for different executables, and what is in NIX equivalent of that?
Right. So there is a feature in Nix language called setup hooks, and Python defines a setup hook. So every package that depends on Python will get appended to the Python path, which is how we specify, how we tell Python to find packages. So if you have package A and package B, and all the each has their own tree of dependencies, they will collect those Python paths and have it available. And when you run a process, that Python path will be configured for you, and Python will be able to import. So if you have like pyramid will have all the dependencies specified in the Python path, and if you have Django, it will have all the dependencies specified in Python path, and then you can run two different processes or something like that. But in Python we have only one Python path, so you can only specify it once, right?
Hello. When you upgrade the library, the version of the library, do you save both versions somewhere, or you remove old version?
Yeah. So let me go back to explain that in a slide. So yeah, here you can see that this is now a VirtualBox running full screen Chromium with a very simple pyramid application. So for example, the way that the hash is computed, right, is that's basically the hash of all the metadata. So everything you pass to the make derivation function is taken and it's hashed. So if something changes, even if you add like another configure flag or something like that, that hash will change and a new package will be built. So everything that depends on this package also has to be rebuilt, because this package is a dependency, and the hash will change for all the reverse dependencies. So new packages will be built, And once the symlink is activated for the profile, it will use the new set of packages. And then if you say rollback, it will go to the previous version of the profile, symlinking to the previous packages that were installed on your system. And the way that you delete actually packages is by calling the function collect garbage. And that is basically a garbage collector that you can specify, like, give me last 5 versions of my profile, and everything the rest you can delete. So the uninstallation is an explicit command to actually remove the packages from your file system. If you say just uninstall, that just removes the symlink from your profile. So if you say uninstall Python and then a rollback, it will just first delete the symlink to uninstall, and when you say rollback, it will switch to previous profile, which has the symlink pointed again to your user environment. So I hope that answers the question.
And yeah, one more question. So as far as I understood, Nix is a pretty old technology. So I have Googled that the first comment was like 10 years ago. So the question is, any reasons to use Nix instead of Docker? Or in other words, any advantages of Nix over Docker? And you have already mentioned that you're planning some integration, some integrations with Docker. So, what's your roadmap on this? Thanks.
So, as this is open source community, there is no really roadmap. There is plans to write the Docker backend, but when that will happen is when somebody will do it. But I would say that Nix and Docker are somewhat orthogonal. So, Docker tries to solve the isolation problem, because we have accumulated so much packaging things that we cannot solve it anymore, so we have to use Docker to isolate things. Whereas Nix tries to tackle the problem with a more technical approach by solving the packaging problem and configuration problem and so on. So you could combine the two and deploy Nix-sized machines to Docker and so on. But I think at the end the question is what use case do you have? If you just have a single Python process that you deploy, then you don't need any of that. Then you use Ubuntu machine, you git clone, and you run that. Maybe you use Ansible or something like that to have that provision. But once you accumulate different services and so on, the problem becomes bigger. And Nix, I think the biggest benefit of Nix is that you can use language to package software, to configure it and to deploy it, and whatever you use you can override and change, and this gives you a great hackability over your packaging. So there is a intersection of problems, but I don't think that it's such a big one. So just 2 more slides. We had a sprint in Ljubljana, Slovenia. I hosted the sprint. This is the last day, so there are not all developers here, but we had about 20 people. This was the second sprint organized by Kyberpipa, which is a hackerspace in Ljubljana, and we hope to do it again next year, if no one else will. And just to show you a little bit of just one graph, this is a graph of contributors per month, so how many people contribute on a monthly basis. And you can see that at the beginning it was just a few people, and now it's really rising, and we're having 130 contributors per month. The latest data is from, it's from September 2014.
Two more questions. Do you have any questions?